Okay, sorry I had to put this one in a separate video. I had some technical difficulties and my computer crashed. So here's the last one, and we're going to do the same things we did on the last two. So let's start by finding the derivative of the function. So y prime is going to be, the derivative of x is 1, and then for the derivative of e to the negative x, let's use the chain rule. So first of all, the derivative of e to the something is e to the something times the derivative of the something. So we get e to the negative x times the derivative of negative x. And the derivative of negative x would be negative 1. So we can rewrite this as 1 minus e to the negative x. And we can rewrite that as 1 minus 1 over e to the x. Okay, now our goal is to set that equal to 0 and find where it's undefined. And anytime you have a fraction, even if just part of your derivative is a fraction, it's a good idea to convert the whole thing to one fraction. That way you can just set the top equal to 0 and set the bottom equal to 0. So what I'm going to do is multiply the 1 by e to the x over e to the x. So I have e to the x over e to the x minus 1 over e to the x. So that's going to be y prime equals e to the x minus 1 over e to the x. So finally, that's the form of the derivative that's easier to set equal to 0 on the top and the bottom. See if I can make that a little more clear there. Okay, so now to find where this is equal to 0, we set the numerator equal to 0, and to find where this is not defined, we set the denominator equal to 0. So starting with the numerator, e to the x minus 1 equals 0. Add 1 to both sides, e to the x equals 1. And then we can take the log of both sides, so that would be, well, the easiest way to do it is just to realize that e to the 0 is going to be 1. Anything to the 0 is 1, so x equals 0. Okay, we don't really need logarithms if we don't have to go there. And so that's a critical point. And then for the denominator, set the denominator equal to 0, but there's no way for e to the x to be 0. E to the x is always positive. So that has no solutions, so we have no additional critical points. So the only critical point we have is x equals 0. Okay, so we can make intervals. The interval from negative infinity to 0, and the interval from 0 to infinity. And we want to find what's happening to the derivative in each interval. So let's put the derivative over here. The derivative was e to the x minus 1 over e to the x. Okay, so let's say we test x equals negative 1 so from the first interval. Okay, so e to the negative 1 minus 1 over e to the negative 1. E to the negative 1 is 1 over e, and that works out to be 1 over e is about like 1/3, and so it's like having 1/3 minus 1, so the numerator is negative. E to the negative 1 is 1 over e, that's about 1/3. Denominator is positive. Negative over positive is negative. Okay, now let's test something else in the second interval. Let's say we test x equals 1. So we have e to the first minus e over e to the first. Okay, e to the first is 2.7 roughly. 2.7 minus 1 is positive over e to the first would be over e to the, over e to the first would be over 2.7, and so positive over positive is positive. That's what I'm trying to say. Okay. Now, what we see is that the original function, boy, this thing does not want to cooperate right now. The original function is going from decreasing to increasing. Therefore, we do have a local minimum at x equals 0. There you go. Sorry, I stumbled through that one. Whew, it's done.